talked about greens quality. Obviously your coffee can only be as good as your greens. One of the reasons that we it's too bad nobody from Cafe Imports is here, so we're going to wax rhapsodic about Cafe Imports. They've been a really great partner for us, and the reason they're a great partner for us is because they kind of give us open access to their warehouse, and we get to pick extremely high quality greens for new roasters to start on, right? So a lot of times, we'll talk about this a little bit, people that start out on the roaster, you know, they don't want to spend a bunch of money on greens because they're not sure that they're going to figure this out. And then they never really know whether it's their roast profile or their greens that are at fault, right? So that's the thing. So Derek taught me this, and I thought it was really interesting. You know, I did the roaster 1 and 2, the SCA thing, and the IDP, and I spent some time teaching in the SCA system a little bit, and I was never really comfortable with the SCA greens grading sheet or even cupping protocol as a way to grade roast quality. That never set well with me. It felt like, you know, all we had was a hammer and everything looked like a nail. So, you know, when we became an SCA campus and we're teaching coffee, and I kind of wanted to move to a little simpler model. So one of the things that we did was we started thinking about green selection as the most flavorful balance between sweetness, number 1. We weight sweetness highest, with number 2, body and acidity is equally weighted. So we're looking for sweetness in the cup to support the innate bitterness, right? We're looking for acidity to intensify the perception of sweetness. And we're looking for body and mouthfeel, because that's really what makes coffee special, right? I mean, I can drink tea all day long because it doesn't coat my palate, right? I can't drink coffee all day long because of that heaviness on my tongue. So that is one of the most satisfying things about coffee, is this body, this lingering flavor, that mouthfeel. So we need that. And on my scale, when I was trying to figure out how to represent this pictorially, I figured the center would be 0 and the outside edge is 100. So what we're looking for is a higher quality green is innately balanced between sweetness, body, and acidity with a higher intensity of those 3 attributes. Right? Does that make sense a little bit? So with regards to new roasters, what I think about is, okay, you know, if your roaster skill is very low and your greens quality is pretty high, well, you can pick a green that'll actually make you look good. I mean, you can do a little drunk driving on your curve and, you know, maybe you have a little variance, but it's still good coffee. It's brand building coffee. It's a coffee of the quality that allows you to sell enough to get more bites at the apple to learn how to run your machine. Does that make sense? So if my skill is 7.5 and my greens are 8.5, my average is 8, I come up a little bit, I'm gaining in wisdom and understanding. And if my skill is 10 and my greens are 10, my average is 10. I'm on an upward trajectory there. Good things are going to happen for me. So better greens carry a long ways you learn to refine your craft. And here's the thing, right? One of the things that happens a lot is people have these questions about, I've heard over and over and over again, online especially, you know, oh, importers inflate their scores. No, they don't. Importers do not inflate their scores. That's not a thing. People are screwing up their sample roasts. People aren't calibrated sensorily. People don't understand how this thing is supposed to work. Or their water quality's bad. I mean, there's this huge galaxy of factors that can deviate on a cupping score from your purchase to your shop. You follow me? Don't scapegoat the importer. Don't scapegoat the machine. And don't blame yourself. Just cut everybody a little slack and find the best way to do this. Okay? Just have some fun with this. Do your best. Pick yourself up. Try all over again. Operator skill, intersection of people and machinery and the green coffee. The number 1 tool of the professional here is intentionality. You should have a concrete target. Now, let's see where I went with this. Here's what you're gonna need. So listen, check this out. I hear this all the time. So Rob Host, peace be upon him, right? Super smart guy, super sweet, great, awesome roaster. He wrote this book, Flavor Profile of Coffee. Completely baffled me. He even came to our place and did a thing, and I was still baffled. Okay? It was like, what are you talking about? It doesn't make sense to me. Well, one of the reasons was I didn't have enough cupping ability, right? Because if I'm gonna flavor profile coffee, I have to be able to taste this and kind of dissect it a little bit, and I have to know that I know that I know. I have to have a library of descriptors to identify the flavors in the cup, right? And it doesn't happen overnight. It's going to take. You're going to have to do it with each other. We're going to have to agree. We got to kind of calibrate a little bit to do this. Machine control. You're going to have to drive the roaster to specific destinations on the curve. I'm going to have to drive the roaster to 9:30 first crack, or 10:15 first crack, or 4:05 and 9:30, or 4:05 and 9:45, whatever it is. I have to have enough control so I can isolate the variables, right? I gotta stay repeatable. I gotta be on target roast after roast. If I'm gonna actually flavor profile coffee in a high level way, I'm gonna have to repeat the roast, change one thing and figure out what that tastes like, and do it again and change something else and figure out what, we're gonna talk about that in a second. Lastly, and Derek talked about it, you're gonna need a flavor target. What did you discern? So check this out. One of the things that happens all the time, we go all over the country, and people send us coffee, right? A lot of it's pretty good. A lot of it's really underdeveloped. Does anybody ever wonder about that? So what's going on with that? I'm going to tell you what I think is going on with that. The only roast profile codified in the SCA system is the sample roast, right? The sample roast is intentionally underdeveloped to highlight defects. Does anybody disagree with that? Okay, just checking, I want to make sure. Because I can be full of goose grease too, but this is what I think. And I'm willing to listen to reason. If somebody wants to talk about it, I'll talk about it, that's fine. The sample roast is intentionally underdeveloped to highlight defects. So what happens when you go to a cupping, and everybody's in this big beautiful room, and you're at the thing, and you're cupping the coffee? Well, it's underdeveloped. I think we've calibrated as an industry to underdeveloped coffee, and we think that's a light roast. Well, that's a recipe for failure at your retail level, because you're giving light roast coffee to people that are completely incapable of extracting it. So he doubles up the dose. He gets a big old cup of lemonade, and he says, "Oh, this hipster coffee is BS." You lost him for a year. Think about that. Just kick that around a little bit. Okay, so most of you guys have seen this. The important parts about this curve represents increasing level of roast flavor. So everything on that side of this line is going to be origin, right? Everything on this side of the line is going to be increasing amounts of roast flavor, right? So our specialty coffee light roasted profile is going to be somewhere in here where my sweetness, body, and acidity are going to be somewhat balanced with my roast level, my roast flavor. You've got a fairly narrow window here where somewhere over in this area where you have moved beyond that grassy vegetal flavors, right? Or that high, sharply acidic acidity flavor. I'm going to keep rolling this way, and I'm going to deplete some of my sugar. I'm going to deplete some of my body, but it's still going to be enough there to balance the cup. And look, right in this area, it's basically as high as it goes. That's about as black as coffee can get, right? So it's a fairly narrow band. Derek mentioned, and this is important to keep in mind, roasting is cooking, right? It ain't science. It's not like that. There's science, and it's good to know. It's good to know. But this is not science. And the reason it's not science is because preference is not science. You are roasting to preference. you are not roasting to the Encyclopedia Britannica. You dig? Okay. So, with that in mind, think about this. In this curve, where on the left side of the line, your coffee is raw. And over on the right side of the line, where your coffee is burnt, there's going to be a median range, and there's going to be a standard deviation encompassing both sides of that line of acceptable roast, right? It kind of makes sense. This is your target. Your target is not this line. You can choose a precise target, but it may not be your target, and your target may not be my target. This is your preference. You decide. Your preference is going to fall out somewhere in this range. So, here's a huge bone of contention. Anybody ever heard of declining rate of rise? Okay? So, let me ask you a question. How important is that to you in your roasting? Anybody? It's okay. If it's super important, that's cool. Nobody's down on it. If it's not important at all, that's okay too. I'm not down on that either. Do you have an opinion? Nobody?
Fred does. Fred?
Okay. I give up. So, this is what I'm going to tell you. If your coffee is balanced, if it's naturally balanced between sweetness, body, and acidity, you've already got that balance in your green coffee. This declining rate of rise idea is probably going to work pretty well. Right? It's a good idea. It's a good thing to do. So here's my question. Why does it work? Nobody ever tells you why it works. Now I'm going to tell you why it works. Maybe some of you know already. Maybe I'm a slow learner. We'll see. So back here, in this initial stage of the roast, if you calculate your real rate of rise out from ambient temperature, right, to 330 degrees, green to yellow transition, your rate of rise is enormously high. In the initial stage of the roast, you might be 50, 60, 70 degrees a minute. How is it possible that we can do that and we don't burn the hell out of the coffee? You ever wondered that? It's pretty simple. It's water, right? The coffee, the moisture boils off and it pushes the heat away. It's designed to do that to protect the seed. It's protecting the endosperm from fire. The seed's job is to propagate. The seed is designed to protect the endosperm. So that is what it is doing. It's the moisture is kind of retarding the absorption of heat into the interior of the seed. So at the beginning of the roast, we are blasting enormous amounts of heat on the outside of the seed. This moisture is kind of shielding the inner portion of the seed. But here's the rub. In 2004, I need to set this down. This is going to drive me crazy. In 2004, a young lady in Dallas, Texas drew a roast graph and she looked up in something the temperature range for Maillard. And she labeled the roast curve in that temperature range Maillard. And for over a decade now, we've been referring to that portion of the roast curve as Maillard. That's not the case. That's not the way this works. This is what happens. In the initial stage of this roast, the Maillard reaction occurs on the outside of the seed. Whatever constituents that are there, whatever organically convertible constituents in that seed that are capable of going through Maillard reaction are going through Maillard reaction in the outer portion of the seed, right? So this is at temperature. As this heats up, we start pulling the heat back to kind of protect the flavors that have been created in the outside of the seed. With this declining rate of rise, we reduce the application of heat so that as the outside of the seed off gases, carbon dioxide and water, we don't start leaving behind carbon, right? So the outside of the seed, it heats up, energy is working into the interior of the seed. We're pulling our application of heat back to minimize this. We're trying to preserve the flavor created in the outside of the seed. Until, finally, the endosperm bursts. Now we've got Maillard in the endosperm region of the seed. Now, if you don't believe me that this is Maillard reaction, all you got to do is drop your coffee in the cooling tray right at first crack and brew it. It's super thin. It's going to be sweet, but it's thin. It doesn't extract. There's the compounds. What is it again? I forget now. Is it furfural? I think that's what it is. The long chain molecules that are created in the endosperm portion of the seed during that Maillard period are not present in the amount to give you the body and the mouthfeel you're looking for. So at this point, we are retarding the roast as much as possible. We've reduced our application of heat. This is the reason that declining rate of rise works. Now, the problems you're going to have with declining rate of rise: underpowered machines, overloaded machines, poor thermocouple choice, because you're going to have to very carefully control it. We're going to talk about this in a minute. And you're going to have problems also if your airflow is too high or airflow is too low, for reasons we're going to talk about in a minute. Where it works is high quality, high grown, high density, washed, well sorted, balanced coffee, where the operator is intentionally maximizing the flavors of origin. If you are going in the second crack, declining rate of rise makes a bunch less sense. You're probably better off with a flat rate of rise if you're doing that. In a lot of cases, on a lot of machines. Not in all cases. That's not a thing. Remember, you decide. You decide what you want to do, cup it out. If it works for you, great. And not all machines are going to roast the same. We'll talk about that in a second. So the question is, why is this so hard to control, right? You're on your thing and you're doing it, and then all of a sudden, whoop, I'm gone. I got problems, right? I got to figure it out a little bit. Okay, this is equally simple. And this is going to make sense. You got this. Check this out. Chemistry is most reactive at heat. The hotter a thing gets, the faster the chemistry change is accelerated. So like back here, things are moving very slow, right? It takes minutes to get this massive amount of chemical change. Over here, at this finish temp area, man, you're roaring. Remember I said 2.5 degrees, 15 seconds? Right? That's it. That's your window. That's your window. The reason is your customers, every single customer you sell to, can probably, I'm going to guess, 5 out of 7 times taste the difference between 405, 410, and 415. Right? Most of us in this room, we can easily, probably 4 out of 5 times we can pick 2.5. A couple of you guys in the room are good down to maybe 1 degree. For real. You got good palates, right? But your target, again, we're talking commercial coffee, your target, you can just keep this, think about it like this, is that last 15 seconds of the roast, the last 2.5 degrees. What is that? So as this temperature heats up, there is probably an equivalent amount of chemical change in the last 45, 30, 45 seconds of the roast as there is in the entire roast. Right? Pretty challenging. Now I do have good news. Number one, 75% of coffee perception, according to Ian Pico, who heard it from somebody, he never told me who. I kind of believe it. Ian's super smart, he's got a really good mustache. 75% of coffee perception is finish temp. Right? For the reason I just said, because everything's moving so fast then. Okay. The exception that proves the rule is what? Non-declining rate of rise. So where might that be a thing? You saw it a little bit in some of the work that Derek did. He flattened his rate of rise out, maybe to kind of tamp down some of that astringency, some of that acidity, right? If the coffee is naturally unbalanced, like especially naturals, right? Maybe you might want to flatten that out. That coffee might actually present better a little baked. Okay? Where declining rate of rise might not work, unbalanced sweetness, body acidity, natural process, poorly sorted. Now this is interesting. Derek and I just talked about this today because this was in the back of my head, but I kind of didn't really understand why it was in the back of my head. And this is super crazy. So we do these YouTube things, and there's like 9 million minutes of viewership on our YouTube channel, like these guys have nothing to do. And a guy from China asked me if he could translate all of our videos into Chinese, right? And I'm like, yeah, that's a little creepy, I'm not sure about that. But then he sent me all this work that he'd done, and he had one of Cafe Import's videos, and Joe was on there. And, you know, Joe worked with us for, I think, over a year, and I never watched those videos because the production values were so much better than mine. I was super embarrassed. And he said something on there, and he said, your poorly size sorted coffee may actually benefit from a slower roast. Like if you take a poorly size sorted coffee and roast it fast, well, some of it's raw and some of it's burnt, right? Where maybe if I flatten that rate of rise and just kind of carry it along gently, maybe I get a lot of sweetness, and maybe I still preserve some of the acidity in the larger seeds. So maybe this poorly size sorted thing works. And again, it was in the back of my head, and I didn't really tumble to why I was thinking that until he said it. So when the operator is intentionally maximizing sweetness or balance, or here's the big one, solubility, right? I can roast for solubility. I can do that. And I can sometimes do that without going darker. Sometimes I can keep that coffee in the roaster longer and maximize solubility without crossing over dramatically into roast flavor. There's a lot of really good roasters that do that. That's pretty neat. Or intentionally depleting acidity. Okay. We talked about you can't cut the curve. Feedback loops. Now this is simple stuff. You got lab, you got data logging, you got sensory. Here's what I'm going to tell you. Lab, roast color, weight class, TDS. At the roaster, we got thermocouples, gas gauges, thermometers, we got drum pressure gauges. We try to stay on top of the bubble when we're roasting. And none of this stuff is useful without sensory cues. The data by itself is meaningless absent the constant context of sensory. You have to know what your coffee tastes like, and you have to know in the trier, because check this out, you guys have super good brains, whether you know it or not. You have marvelous, genius, unbelievably lazy brains. What you are designed for is pattern recognition. If you're standing at the roaster and you're actively engaged and you're pulling the trier and you're paying attention, you will naturally absorb by osmosis. It might help to sleep with a trier under your pillow. It could be a thing, right? You will absorb, you will start to pick up on this. Hey, this scent is such and so, right? Or I'm watching the coffee swell. It's still a little wrinkled. It's not quite expanded enough, right? So Derek said something to me the other day that it's like people say things and you know immediately that it's true, but you don't really know why. So he said, not all 405s cut the same. So like we're production roasted, and our profile says we finish at 405, right? But check it out. They don't all cut the same. Because the roasts are different sometimes. Even though they look the same, they're still a little different. Sometimes there's not the expansion. And the reason is because there's no way this is the limits of automation, by the way. There's no thermocouple, there's no measurement device, there's no way for you to perceive the amount of energy that is latent heat locked up inside the system. You can only see what it does, right? The heat's there, you can't see it, but you can see the effect on the coffee. You can smell the effect on the coffee. You can see how the coffee is changing over time and recognize that and use that to your advantage. This is called craft. This is what it is. This is the underlying basis of craft. Machines can't do this. Now, listen, I'm a really good engineer. For real. I'm good at this. I'm a highly advanced, highly sophisticated tool user. I've worked on some of the coolest stuff mankind has ever created, for real. Like the machine that prints Oreo cookie fillings, that shit was cool. Okay? I've worked for NASA. I've worked for Nabisco. Nabisco would have been to Mars 20 years ago. They'd already be baking Oreos there. For real. These are the smartest people on the planet. There's like this childish faith in engineering. Like, oh, it's going to solve all of our problems. Yeah, this isn't a problem engineering can solve. All I can do is build you a slightly better tool for your brain to use. That's all I can do. If anybody tells you that you're going to push the button and get perfect coffee time after time after time, that dude don't roast coffee, number one. And number two, whoever told him that is full of goose grease. That's it. End of story. Okay. So, I'm sorry, I got a little heated there. Machine control. Now this is where things get a little exotic. I'm sorry to bore you with this. Here's a clue. You're going to need heat. Okay? You're going to need kind of a lot of heat. And you're going to have to find a machine that can actually make use of it. Okay? Now what that means is, your roaster is a system. Now, like the first time I went to the SCA show, they were like, you know, I was shopping for a roaster. I hadn't built a roaster yet, I was shopping for a roaster. And I go, and the guy said, oh, you gotta have cast iron. It's just like a pan, you just gotta sear that steak. I'm like, yeah, I don't think that's a thing, man. That don't bear witness to me, right? Then the next guy says, oh, you gotta have carbon steel drums because you're gonna get stainless hot spots, right? Like I should get an inoculation against hot spots. Yeah, that ain't a thing either. Okay? Here's the deal. Your roaster's a system. Somebody had a brain, ideally, or they copied something, which is what usually happens. Usually manufacturers just copy somebody else. Because they don't roast coffee. There's a dirty little secret. Manufacturers don't roast coffee. They don't. You guys roast more coffee in a week than they do the whole year. Right? We are the exception. That's true. But most of these guys, they don't roast coffee. And I can guarantee you the sales guy don't roast coffee either. Okay? You getting this? So when this dude says, oh, hot spots. Well, what if I just had a more diffuse heat source? Would that be okay? Or what if my stainless steel was like super, super thick? Would that be okay? Oh, no, it's hot spots. Shut up to me. That's stupid. It's just dumb. What I'm telling you is your roaster's a system. So, for instance, just as an example, if you had a single wall drum, the hottest portion of the drum initially is going to be down at the bottom by the heat source, right? Duh, it's conduction, bang, it's hot. But then it goes up, it's on top. There's going to be a gradient, there's going to be a differential. It may be a little, it may be a lot. It's going to be less if the drum is thinner, right? Or it could be more, depending on the airflow. That's an interesting thing too, because airflow matters. If you got a double wall drum, a lot of people like double wall drums because the outer drum has a greater gradient, but the inner drum is relatively stable. I am not here to pitch you on my roasters. I'm not even going to mention my roasters. We're not talking about that. What I am here to tell you is the reason double wall drums are kind of cool is because it makes this interior drum marginally more stable and more controlled. That's all. This is not a killer thing. It's not an automatic guarantee of coffee. It just makes the machine more controlled. That's it. Here's the other thing a lot of people misunderstand. Every single thermocouple, every inch in your drum, coolest temperature inside the drum is at the bottom of the drum, hottest temperature is at the top. Your bean temperature probe is probably going to read anywhere from 10 to 30 degrees lower than your environmental temperature probe. This is the reason that Derek mentioned that we charge on the PID thermocouple just because I made the decision. I think the PID thermocouple is closer to the center line of the drum and it reads back for preheat and more true reading. That's what I think. I could be wrong. You can do it any way you want. It's a relative reference. That's how we do it. So, bean temperature, lowest temperature, PID, marginally more average, environmental temperature higher, and then we add an incoming air probe just because I want to know the maximum temperature of the heated air coming into the system. Because if I look at that, I can adjust my airflow at any given gas setting, any given fuel setting for maximum efficiency. That's why I do that. Okay, let's talk about drum size for a minute, because there's confusion about drum size and how this thing works. I think, personally, I think about 1/6 the volume of the green as the drum size. So if it's a 10 kilogram drum, my volume is probably something more like 60 kilograms total. That's it. The reason I do that is because I think coffee swells up to maybe 2.5 times its green size in the course of the roast. What I need here is loft. I need loft. I need to pitch that coffee up into the airstream for convective heating. So what I want to see is my coffee at finish. I want it to be below the center line of the drum. That would be the drum shaft. One of the things is we talk about conduction, we talk about convection. So Probet, eons ago, decided that roasting was 30% conductive and roughly 70% convective. So here's what people don't know. Your drum roaster, the way it operates, it mechanically fluidizes the bean mass. So there's fluid bed roasters, we've all heard of those, and there's drum roasters. And they're like, oh, it's a divide that cannot be crossed. Yeah, it's kind of true, it's kind of not true. The drum roaster operates on exactly the same principle. The only difference is it mechanically fluidizes the bean mass. That's it. The reason it mechanically fluidizes the bean mass is because the convection heating, 70% of your heat is going to come when that seed is completely encompassed in air, heated air. So this point-to-point contact on conductive heat transfer is 30%, but because it's only point-to-point, whereas your convection is over the entire surface area, it's a much more efficient heat transfer. You will see, let's see if I got this here. So when I set my airflow, now this is interesting. Airflow will exist on a curve. The roaster's is a big block of iron, right? And you charge that up like a thermal battery. As I increase my airflow, there will be a range of increase where I'm actually going to get a higher rate of rise. You've all seen that. You've turned up here and suddenly, bang, you get a higher rate of rise, right? Until you hit this peak, you increase your airflow again. Now you're bringing dilutive air into the system that is greater than the machine's ability to heat it, and now suddenly you start to cool your roast, right? Simple, easy peasy. So this is your curve. You're gonna have to know this. So Derek and I talked about this on the drive. You know, why do we change airflow? We do in our normal roasting procedure is very, very low airflow initially, because we kind of want to keep energy in the system, especially if we're doing the soak. We'll talk about that in a second. And we increase airflow coming into green to yellow a little bit, because now we're carrying chaff out of the system. We want to get that chaff out of there. And then lastly, immediately prior to first crack, we're going to bump up the airflow again to deplete the energy, because I want to slow that down. I want to bring my rate of rise down from 12, 13 coming into first crack to sub 10, so I can get development. I need time to work energy into the center of the seed. So, simple. Remove chaff, blah, blah, blah. Okay, remove heat next. So that was super trick. Okay, now, go back to declining rate of rise for a second. One of the problems that people have all the time, they get all jacked up because they're going to need a relatively high rate of rise to start initially to bring that down controllably, right? If you have a thin thermocouple, you will have a low turning point, because there's two wires welded inside that thermocouple. That's called the junction. That weld is called the junction. The junction, the turning point, is when the junction is the same temperature, essentially, as your green coffee. Got it? So just like a small seed versus a large seed, that thin thermocouple junction will hit equilibrium with the green coffee at a very low temperature. Easy, right? But when it does that, because this rate of rise curve is the first derivative of the slope of your bean temperature, the math behind this, you can look it up on Wikipedia. Okay? So the lower my turning point is, the higher my rate of rise is. Just remember that. That's a super simple part. So here's what happens. If I have a thick thermocouple, guess what? I'm going to have a much higher turning point because it takes time to work the heat in to be equilibrium at the junction with the green coffee. And I'm going to have an extremely low rate of rise. These are the exact same profiles. These are the exact same coffee, the exact same BTU, the exact same therms, the exact same heat transfer. One thermocouple versus another. Low versus high. You get it? So just know that that's a thing. Don't look at somebody's curve and think you can emulate that and get frustrated when you can't because you don't know what their coffee is, you don't know how their machine works, you don't know what their thermocouple is. As Angie Davis would say, you got to keep your eyes on your own paper. Okay. Drum speed. I'm going to set a drum speed that mechanically fluidizes the bean mass to increase convection. Now, generally higher for larger batches, lower for smaller. If your drum speed is too low, I'm going to show you this in a minute, we're going to skip ahead, or your batch is too high, because that's the same thing, too big a batch will create the exact same condition as too low a drum speed. I'll show you that in a second. You're going to have buildup of chaff and you're going to end up imparting roast flavor into the coffee sooner. You're going to have smoky coffee. If you want smoky coffee, it used to be a thing. I mean, anybody roasting an old Probat where it's got the aroma roast thing? Right? That's what they do. They cycle it back for yum. Okay. Too high. If your drum speed's too high and that coffee's just pinging all over the drum, you're going to have super erratic thermocouple response, right? Because that thermocouple needs to be in the bean mass. Now, here's the thing. A higher drum speed can allow you a much higher charge time too. So if you're on an older roaster that doesn't have all the bells and whistles and all the fancy whiz bang stuff, sometimes you can pump up the drum speed just to get higher charge temp and boost that your roast a little bit. Okay, so here's the graphic. If my drum speed is slow, that green coffee is riding on the surface of the drum, it's more conductive. There's more contact time between the drum and the seed. There's more energy transfer from the drum to the seed. Got it? Simple. Easy peasy. And because the coffee is lower in the drum, it's less convective. This is how Diedrich works, by the way. This is the Diedrich roaster. Diedrich is a very thin-walled drum. It's got a relatively low-powered infrared burner underneath it. And the way that you profile specialty coffee in a Diedrich system typically is to reduce your batch size, sometimes as much as 50%. It's because of this. This is the thing. It's especially that with the older IR12s that were rotating at about 33 RPM. All right? That's how it works. Okay. If your coffee is fast, you do have less dwell time per revelation, less contact time, but that coffee is turning over more often, so you actually have more contacts. So it's not a linear thing. There's a little more nuance to this than people would expect sometimes. But you do loft the coffee up in the airstream, and it is enveloped with that heated air. This could be a good thing. Okay. Same deal. Fixed drum speed, the way that you change your conductive-convective ratio, the way that you would with variable drum speed is to reduce or increase your batch sizes. Got it? No big deal. Now we're going to talk about the soak for a second. So Derek referenced stop and go, he referenced soak. I'm going to tell you why the soak works. This is what the soak does. What the soak allows you to do is you turn off your burners, and the only heat that's being imparted to the seed is from the inside of the drum, essentially. There's going to be some convection also, but you don't have the flame lit. You follow me? So what's going to happen is this green coffee is going to deplete the energy out of the drum so that when you turn the burner on, you will recognize, you will see in your data logging a nearly instantaneous response. The soak is a way for you to deplete the energy in the system to a point where turning on the gas has an immediate discernible response. It's a control mechanism. There's nothing mysterious about this. It's not automatically good for your coffee. It doesn't, that's not the thing. Your coffee is going to taste any different, but it's going to help you control the roast more precisely. You can do this on small machines with big thermal mass. It is, generally speaking, much more difficult to do that on large machines at full batch size. There's just not enough heat there. Sometimes there is, sometimes there's not. Depends on the coffee. Okay. Machine control solutions. The first thing you can do, if you're roasting on a machine, you don't have a bunch of variable stuff, you're relatively low power, you reduce your batch size. You can increase your charge temp to the limit of the seed. The system, the drum itself, the rotation, the mixing, the airflow, everything that goes into this machine will allow you to preheat to a point where it'll create chemical defect in the seed. You'll have chemical. Everybody knows tipping, scorching, and facing. That's simple. You can see that. That's mechanical defect. But there is a precursor to that. It's about 5 or 6 degrees before the onset of that. You are still damaging your coffee. You're still heat shocking your coffee. If you grind that coffee and smell it, you'll pick up a very sharp, acrid tang to the grounds. Instantly. It will be there. You can't roast that out. If you get that in your ground coffee, you need to reduce your application of heat, or you need to reduce your batch size. Or both. Got it? You can manage your airflow to the highest rate of rise, to your highest rate of rise point. That is the maximum amount of heat that you can impart, to the limit, again, of heat defect in your seed. You're going to have preheat and between batch protocols, maybe the soak. You're going to find ways to manipulate the system so that you are more consistently starting at a point you understand and you can control your roast. And a lot of times it helps just to remove all your smoothing. So there's an obsession in the industry with these super perfect roast curves, which I don't know if you can tell, but we're kind of anti that a little bit. It's fine, it's super good. Take your smoothing off. Because the smoothing retards your thermocouple response by 3 or 4 seconds. You're already in a different trend by the time you see it if you're smoothing your roast profiles. Take the smoothing off, use your brain to monitor trend. Your roast will improve, 100%. Keep it simple. Okay, so here's the deal. Derek's roasted millions of pounds of coffee. Most of you guys have roasted more coffee than I have. I'm not a genius roaster. I am a competent roaster. I get a roast coffee you want to drink, 100% for sure. I know how to do this, but I'm not practiced at it. I needed a kind of a protocol to break this down and keep it simple for me. So what I decided to do, I figured that, okay, if my finish temp is, if my roast is most reactive at heat, I'm going to pick a finish temp. I'm going to do my initial roast profile. If I am underdeveloped in my initial roast profile, I'm going to repeat that roast profile. Maybe it's a sample. Listen, I'm going to tell you exactly how I do it. And I'm not saying this is the best way, but this is me. I'm going to roast green to yellow transition about 4:35. I'm going to roast first crack at probably 8:30, 9:15. I'm going to give it a minute 15 development. I'm going to start pulling the trier. I'm going to smell that sweet scent, that Maillard in the portion of the endosperm, that furfural, right? I'm going to smell that sweet scent, which will be overcome about 15 seconds later by a very sharp acrid, which I think is a ketone of the cellulose on the outside of the seed coming apart. I think that's what that is. I think the furfural is still there, but I think that ketone overwhelms it. About 15, 20 seconds later, depending on the exterior development, I'm going to drop that. That's my first roast. If I put that on the table and I cup that out and it's underdeveloped, I'm going to take it another 15 seconds and then another 15 seconds again. I'm going to put all 3 on the table and I'm going to cup them out and I'm going to pick a winner. That's how, if I am trying to not cross over into roast flavor, if I am trying to maximize flavor of origin, that is what I am going to do. That's my roast. I'm going to pick a finish temp. Then, I'm going to come back here and I'm going to roast to the exact same finish temp, except this time, I'm going to extend my development time. I'm going to maintain my first crack time, but I'm going to manage my roast, so I extend my development time after first crack by maybe 15 seconds and maybe another 15 seconds. That gives me 3 more cups. I put that on the table and I'm going to cup that up. I'm going to pick a winner. You get the idea? This is super simple. Tell me why I start over the right side of the curve? Because chemistry is most reactive at heat. Tell me why I'm not making big, huge changes? Because chemistry is most reactive at heat. Tell me why I can do this? Because I got machine control. I can control a machine like this. I can do that. I have that capability. If I can't, then this is an exercise in futility. If I can't cup it and taste the difference, this is an exercise in futility. I'm not saying you shouldn't try. I'm just saying that you're going to be extremely limited. If you can't control the machine, you can't cup the roast, right? So then, now I've got a development time, now I've got a finish temp. Now again, Derek's done this for over a decade. Derek can hit my target in 3-4 roasts. No sweat. It's going to take me 10 or 15, but you know what? I can get there. I'm just doing the work. Okay? So then I'm going to come back. Now I'm going to change my onset to first crack. I'm going to take this back 30 seconds. I'm going to take it forward 30 seconds. Not 15, because I'm not hot now. I'm hot, but I'm not as hot, right? So I push it back, I push forward, and I cup it out. Now I got 3 more roasts. I cup that out. I can work my way all the way back to the beginning of the roast, all the way to my preheat temp. This way. And did I mention coffee's got to get to the obsessive compulsive? If I really want to, I can work my way back the other way, right? I mean, somewhere in this process, I'm going to actually end up with a pretty solid cup. That's how I do it, because I don't have your experience. But this is a framework, and I think it perfectly illustrates a way to approach this if you're just starting out, or if you're just trying to get some traction on this. So what you're going to have to do, you're going to have to be across the table with people and start cupping, develop a library of descriptors you can depend on, right? You have to do 150, 200 roasts at your machine to learn how to drive your roaster to specific destinations on the roast curve. And then you just got to put in the work. Good things are going to happen for you. That's it. Ta-da! You've now successfully survived.